Right, everyone. Let's get going on the OGC session this time. Again, my thanks, Lutz and Peter, for allowing OGC an opportunity to give you an annual update of sort of what we've got going on at this TC211 plenary. What we have today is a introduction from me about just some general activities and recent events at OGC. And then we're going to step through description of a few projects underway that should be of interest to folks. Peter Vertanos will join us to talk about the building blocks with OGC API records standard. Yujun Lee to talk about indoor GML implementation of the ISO 19164 indoor feature model. Then Ivano is in the room with us. We'll talk about some of the testbed 18 work regarding training data for artificial intelligence and machine learning. And then Chris Little, who's online, to talk about moving from heavy standards to lighter standards and a whole bunch of other pieces in there. That's a really fascinating topic. And at that point, if we have some good time left, we're going to talk a little bit about some new emerging topics in OGC, our modular specification and what we might want to do with it and how we relate that to ISO TC211, GeoDCAT and its place in the spatial community, and GeoDCAT as related to ISO 19115. So with that, let me just jump into what we've been up to since May. We've gotten really busy again. Some just interesting statistics. OGC normally publishes almost precisely 16 standards per year. Weirdly, it's been 16 per year forever. First year of COVID, it was only 15, but that's not too bad. Second year of COVID, it was 12. And in 2022, we're on track to only publish 4 standards at the beginning of the year because productivity had just cratered in this virtual only world. We had a meeting in Madrid, and then in Singapore. The Singapore meeting, we had a record for the most number of standards events to vote ever in OGC's history. So getting together physically just seemed to break loose the tide. And so now we've already had 8 standards published this year, or since May, and more on the way. So standards here, you'll see interest in TC211 OGC API tiles for sure. We have a new abstract specification topic. Those are our conceptual fundamental models. We've taken the GeoPackage standard and detached it from the mandatory encoding of using SQLite. So we now have a conceptual model for GeoPackage. Coverage JSON coming in for the community standard is another way to represent coverage data, and a handful of others. A new best practice published on use of sensor things for citizen science data that will be moving towards a standard. A couple of engineering reports reporting back on the efforts we've done jointly with IHO on federated marine spatial data infrastructures, particularly dealing with marine protected areas and the limits and boundary standards in IHO, and a report from one of our recent code sprints held jointly with OSGeo Foundation and Apache Software Foundation. A couple or 3 discussion papers. We have 2 new working groups. One domain working group for climate resilience. We had all sorts of discussions about what part of climate we wanted to talk about. We decided climate resilience was a good focus. We talk about all the climate change issues. It's just too broad of a topic. So let's have a bit more focus. And another working group that will be officially live in a couple of days, Geo for the Metaverse domain working group. Talk about the geospatial aspects in this evolving Web 3.0 metaverse, whatever we want to call, and it's going to change its name, I'm sure, 5 more times in the next 5 years. But at least for now, people call it metaverse. And just what components might we contribute? Primarily, our discussions are revolving around digital twins at this time. There we go. For those of you that want to attend OGC member meetings, like I said, we've had 2 this year. We were in Madrid in June, Singapore in October. And the week of 20 to 23 February, we'll be in Frascati, Italy, the outskirts of Rome, for a member meeting. 5 through 9 June in Huntsville, Alabama, in the southern U.S. While it's really hot already, so that'll be super fun to go sweat. And if you want to keep sweating, you can go to Singapore again in September, October for our final member meeting of the year. We're down to 3 per year now instead of 4. We've stopped doing our December member meetings, but as we speak this very moment, a bunch of OGC people are gathered in Washington, DC to go over some of our innovation projects. So we're doing an innovation days in theory towards the end of each year. Normally it should not overlap with TC 211. It's very unfortunate that this year, but certain sponsors didn't give us other options. Just for those of you who aren't familiar with our standards roadmap, we publish a roadmap of all of our active standards. It's updated about once a month, even though these things probably should update daily. I just don't have time to do that. And to show you kind of what's in the queue right now, highlighting on the right, the stage in which the standard is. If it's a green checkbox, it's been completed. If it's in orange, it's in work. And so you'll see a number of standards. Few abstract specification topics jointly with ISO TC 211 is that first one, topic 20. Observations, measurements, and samples. We will publish that once ISO publishes. I noted the GeoPost standard was recently published, so that needs to go from my orange to green. And a handful of the OGC APIs, so the common APIs, coverages, more on features, maps, records, etc. And as we just talked about a little while ago, the two-dimensional tile matrix set and tile set metadata for descriptions of tiling data that are foundational for the OGC API for tiles. And speaking of the OGC APIs, the roadmap that no one can read, it's really hard to see. Sorry about that, folks, but these are all the API components in work right now. So the OGC APIs, which are published, at least the features one as the geospatial API features in ISO TC 211 19168. These are all the APIs under work. You'll see in the large light green box is the general API family, and then underneath it all the various parts in either gray or darker green boxes. And just time progresses to the right. There are no longer any years on this diagram because it's increasingly inaccurate at all times. But those that are in the darker green, we've moved forward, and the ones in gray are in progress. And so you'll see we're working on other parts for the features, 19168. We have one underway for routes, discrete global grid systems, moving features, etc. Lots of OGC APIs in work right now. These APIs are all constructed of building blocks. These are little modular components that equate maybe to one or more requirements classes, but describe a discrete piece of that building block, that API that can be reused elsewhere or used to build a new API. And we now have a website for these location building blocks where you can explore and identify the building blocks that might be best suited for your use. When you search that building block registry, you'll see building blocks. I've got a couple of them here, one for collections, one for a collection. Highlights whether it's from a valid current standard or if it's in work, and the relative maturity. There's a maturity scale that's also linked to this site. Mature means something that's reasonably well implemented. And once you go to one of those building blocks, you get information, how it works, what it does, the properties, even sample code. So those of you that want to make your own implementation of any one of the OGC API standards or the discrete building blocks can go to this resource, grab some sample code, blast it all together, and in theory, you've got a working implementation. We exercise all these OGC API standards and increasingly other standards through a series of code sprints. We run several a year. It's this 2022, we did 5. These are typically about 3 days long, open to anybody. In September of this year, we ran the metadata code sprint jointly with ISO TC 211 to look at the OGC API for records in conjunction with the STAC standard, spatiotemporal asset catalog to describe electro-optical imaging data, well, any remote sense data now, built on top of OGC API features or ISO 19168 and ISO 19115 and the features and geometries JSON. So experiment with those in context, there's relationships between them, and it's a great opportunity to see if the standards are implementable. We just completed literally last week our web mapping code sprint to look at the OGC APIs for tiles, maps, styles, and then the styling and symbology conceptual model. So again, to exercise these in concert, because if you want to put a map on the web, you're going to have to style that map. Otherwise, it's not particularly interesting. So let's ensure that those APIs work together and reinforce each other. These code sprints don't just increase the rate of work that we perform on standards. they ensure that when standards are released, they're implementable. And I think that's really critically important. They also tend to result in reference implementations right out of the bat. So standards approved and it's already implemented. So the last big topic I wanted to go into before we jump to our real important people is some new efforts in OGC. We held a location powers event. These are sort of OGC brainstorming events where we bring in people from outside the location and geospatial community to talk about a topic where we think there's location relevance. And so we wanted to talk about ESG, environmental, societal, and governance investing. We brought in folks from the insurance industry, the financial industry, the credit rating companies, as well as some spatial experts to look at what are those things that we can contribute to the ESG community to ensure that these ratings that people do to tell how good a company or a community is with respect to its environmental, social, and governance rules and behavior, and make those more consistent. This was held in London in the financial district just a few weeks ago. Really good and diverse attendance. It really hurt my brain because I don't know anything about the financial industry and I learned way too much, many things I don't want to know. We focused it on sort of 6 clusters of communication. So initially talking about investments and reporting. What are the motivations and drivers for investing in companies that have good environmental reporting? All of us who care about the earth, yeah, maybe we can see that, maybe that's obvious. If you're an institutional investor, that may not be as important to you. So what are those returns that perhaps these companies that have a good track record in ESG satisfy? Where is geospatial used in making those calculations? If you're ranking someone on their carbon footprint, how do you calculate the footprint of that business? Is it just on the emissions from their power supply that they're buying from some third party? Is it a matter of how much forest they're clearing to grow their cattle? How do you determine their carbon impact, for instance? We had some discussion on the business models from bankers, logistics and construction industry. And then we delved a lot deeper into the technological aspects. So understanding why you might want to use geospatial factors in making these calculations, what's out there with respect to data and technology. Finally, we talked about those key characteristics of the geospatial pieces we would contribute and looked at what standards might be available for the community that we in our geospatial world have already published, or what new standards might we need. For instance, there is a strong desire, we have several people trying to bring into OGC right now, a standard for carbon metrics, a carbon counting standard. How does one calculate how much carbon is encumbered in some part of the environment? And how do you show the basis by which you made those calculations so that they're comparable? If I count tree crowns and you count the width of the tree, are they the same kind of carbon count that we're doing? We will be publishing a report on this in the near future, but a few really interesting outcomes. Trust in all caps. That's interesting to the financial industry, but it's trust above completeness. So when they look at a data set, they will risk away incomplete data. If they don't have all the data they need, they will put that into the risk calculation. What data they have, they must trust. So the chain of custody, the processing, all the massaging you do of data through the process must be validated, verified, and given some factor of trust, even if you can tell them that it's not complete data. And then we, as I kind of noted about this risk, have a lot of concern about absolute values. The financial industry really doesn't care how precisely located something is, so long as they can use risk as a factor in this. We don't speak their language at all. It was pretty shocking after 2 days of this meeting that we were still talking at cross purposes about what we consider to be good data and what a financial person considers to be good data. It's all a matter of risk that we don't really talk about. So it was a really, really interesting location powers event. I think it will be impacting a number of OGC working groups, the climate resilience working group, clearly from the environmental side. On the social side, it becomes a little bit more challenging, but when you talk about population dynamics and financial inequality in the world, these are spatial calculations. We understand those. The governance side, I think we agreed after 2 days, there's not a whole lot that we in the spatial community can contribute. I don't know what the spatial characteristics of board compensation are, how much you pay your board of directors. those are the kind of things that we don't really touch much upon. So that was a bit outside our realm, and that's okay. And then finally, our innovation efforts in OGC. So we're renaming our innovation program. It's now COSI, not like the Cozy Cone Motel in the Cars movie, but rather COSI, which stands for Collaborative Solution Innovation. The main rationale here is whenever we would say IP, everyone thought we were talking about intellectual property, not our innovation program, and that just became too much of a pain. So we renamed that program. You'll see that in future communication from me. And we've kind of recharacterized our projects into 3 general buckets. So fundamental research, application of standards and research results to the real world, and then finally building communities around standardization. So if you look at the kind of projects we do, a lot of the European Commission work is in those first 2 buckets. It's more fundamental applied research or application of those results to real world scenarios. And off on the far right here, the pilot projects we've been doing in the marine community, disaster management, climate resilience, et cetera, where there's far more effort put into actually bringing community members together and less on the actual technical work. And as I noted, we have this meeting going on as we speak in Washington, D.C., looking at our disaster resilience and climate projects and a workshop to help further those along, as well as preview some of the work from our upcoming testbed results. So with that, that's all I had on an OGC update. If we don't mind for questions and such, we'll kind of wait till everyone's had a chance to present, and then we can talk about this in a bigger context. So a little bit fast, but I want to get everyone else to show up here too. So now I've bored you to death with all the OGC stuff. Let's talk about the more interesting stuff. So as I noted, we have a few presentations from members to talk to you about these following topics. And so I'm going to look real quick, folks. Sorry, I'm here. If Peter is here, there's Peter. And Peter, I can bring up your slides for you unless you want to do that yourself.
No, I'll do it myself, Scott, if that's okay.
That is wonderful. Oh yeah, once your screen shows up, I'll be there.
You can, oh, you got to stop sharing, it says.
Oh yeah.
Right, okay. All righty.
Here
we go. All right. What am I going to share here? I am going to share that. Okay. Hopefully you guys can see that. Yes?
Yes, we can.
Okay. And can you see it? Can you see it now?
It's thinking, yes, we see full screen. Thanks, Peter.
Okay, excellent. So good morning, afternoon, whatever appropriate time it is for everyone. My name is Peter Vertanos. I work for CubeWorks, now MariaDB, and I'm going to do a presentation on OGC API records and the building blocks that we use in the specification to create catalogs. So the agenda is going to be pretty straightforward. I'll cover some use cases. I'll go into a little bit of description of each of the building blocks that we use for catalogs. Then using those building blocks, I will describe 3 types of catalogs or 3 deployments of catalogs. I'll get into a little bit of the details of the resources and the APIs, and then a Q&A, I guess, later on. So the use cases that we use to drive the development of the specification are pretty straightforward. We want to be able to integrate existing legacy CSW servers into the OGC API framework. And the way we do that is the way we did with WFS. You can build an OGC API facade on top of the existing service so that you can play in the OGC API framework space. The other use cases are kind of general discovery portals where you have resources that you want to make discoverable. Local resource discovery portal, I'll get into detail about that specific subcase as I go through the presentation. Another use case was the catalog as a repository or a registry of code lists or metadata documents You want to be able to store those and search those or discover those. And then we want to be able to enable simple, fast navigation through hierarchically organized collections of records that are describing things like EO products or data sets. Preferably, this last one is executable by humans, i.e. using their browser. They can crawl through the catalog, and machines using crawlers. So a machine can basically find where the root of your catalog is and then crawl it to harvest it or to search it. So the building blocks. The very first building block is the atomic unit of information in the catalog. It's the record. It's a set of properties that are generic and are meant to describe any kind of resource. The intent is that the record acts as a kernel of information, and then specific communities of interest or use cases will extend the record by adding properties to it to satisfy their requirements. Another building block is we have a JSON encoding of the record, which is basically GeoJSON. We also have an HTML encoding of the record, which just has some requirements for HTML. We don't really tell you what to make it look like, but we do have some requirements that you have to include in there. The next building block is the collection. So we have the record, and now we have a collection of records, which is called a catalog. And the collection building block is just the description of the catalog, basically. We have an API, which is the OGC API Features API Plus. We've extended it. You might know it as ISO 19168. So that's the API for searching a catalog. We've added some additional query parameters to that API that are catalog specific, things like keyword searches, type searches, etc. And those actually are now being absorbed into features. So they're going to be taken out of records and they're going to become part of the feature specification, so that the entire API for the record for a catalog is described in the feature specification. We've added a sorting building block so you can sort the results. And again, sorting is going to be absorbed into features so that all of the API components of the catalog are going to be in the features specification. For advanced query capabilities, so OGC API Features or ISO 19168 has a certain level of search capability, basically bbox, datetime, and property equals type predicates. CQL extends that to add a more complete query language to the picture, so you can add the building block, the CQL building block, if you want to support advanced filtering in your catalog. And finally, we have Atom and OpenSearch. There's a large component of our community that still uses OpenSearch with Atom. So we've added these building blocks as well. So if you want to implement those, you can, and support that community as well. So now we have all of these Lego blocks and we can assemble them into different ways. And the ways that we can assemble them, or the ways that we've chosen to assemble them in the catalog, are to define 3 types of catalog deployments. The first one we call a crawlable catalog. The next one we call a searchable catalog, and then a local resources catalog. We're sure there are other ways to put the building blocks or your Legos together, but we don't talk about that in the specification. So let's talk about crawlable catalogs. So you have a bunch of resources sitting out on the web. Let's say they're images or Earth observation images in S3 buckets. To create a crawlable catalog, you create a record for each resource, possibly with a JSON encoding or an HTML encoding for the record. And then you link that record to the resource so that if you find the record, you can navigate to the resource. Then you can take a bunch of these records and create a collection or a catalog by creating a collection object. Again, you can code that collection object as JSON or HTML, link it to the catalog records. So now if I tell you this is my catalog and I give you the link to the collection object, you can crawl to the record objects to get a description of the resources that are discoverable, and then you can crawl to the resource itself to actually get it. So that's the crawlable catalog. This TLDR is just in the slides for your reference. It basically just describes everything that I just said, so that when you read the slide presentation later, you know what the previous slide is about. Okay, so the next catalog deployment that we describe in the records specification is the searchable catalog. So again, we start with a set of resources that we want to make discoverable. Searchable catalogs are usually backed by some database. Searchable catalogs also have some engine that performs the searching. In this case, it's OGC API Features API or ISO 19168. So you implement that. Then you can also implement the additional building blocks that we described earlier, the query parameters for querying the catalog, CQL for supporting advanced filtering, sort for supporting sorting, and even the OpenSearch and Atom conformance classes if you want to support that API as well. So now you've implemented all of this in your feature server, and you can start creating records that describe each of the resources that you want to make discoverable. Those records end up in the database. Once you have that done, you can do something like what I'm showing at the bottom here. I'm saying find all of the records in this bounding box during this time. The Features API executes that, identifies the records that satisfy the query predicate. Once you found the records, you can navigate to the resources that those records describe and use them the way you want to use them. So that's a searchable catalog. Again, this is the TLDR. It's for your reference. Okay, the last one is the local resources catalog. Now, I'm going to break out of here for a second. One of the things that I do is maintain this thing called the OGC API resource tree. And what it is, it's just an HTML page where I describe all of the endpoints and paths to all of the resources that we are developing in OGC. Well, most of them. I mean, there's obviously some lag. I can't keep completely up to date. So anyone who's seen OGC API features will be familiar with this. It starts off at the root, which is the landing page, and then you have the API conformance endpoints, and then you have the collections endpoints. So if you expand that, you have the various collection types here, coverages, processes, maps, tiles. A special collection type is the record, which is right here. I just separated that out to highlight it. And again, if you break out the items, you'll get to the individual records. And I also have a description of what each of the methods does at each of these endpoints. Now, some of these endpoints, such as the collections endpoint, behave like mini catalogs. In other words, they give you a list of resources that are available that you can access. So the collections endpoint, for example, is an example because it gives you a list of collections that are available locally at this deployment. The images endpoint is another type of sort of mini catalog endpoint because it has the list of scenes and some metadata about those scenes. So in the OGC API record specification, we describe something called a local resources catalog, which is essentially taking these endpoints that are in the OGC API resource tree, extending them a little bit to make them behave more like OGC API records catalogs. So the way that works is you implement one of these endpoints. Let's say I implement the collections endpoint. So normally when you go to that endpoint and you do a get, you'll just get a big long list of collections. But if you implement the query parameters that are described in the OGC API record specification, if you implement CQL for advanced filtering, if you implement sorting at that endpoint, you can then execute a query like this, which is more than just a get. It's a get on the collections, but you have some predicates saying, I want all the collections that intersect this bounding box and have a relevant time within this time period. So that's what we call a local resources catalog. It's called a local resources catalog because it's a catalog of resources that you've deployed locally through an OGC API deployment. And there's the TLDR. So if you read the slides later, you'll know what I'm talking about. Okay, so in the specification, we have a bunch of conformance classes, which I've listed here. And then for each of these conformance classes, I map it back to the building blocks that I introduced early on. So we have the record, we have the collection, we have the query parameters that are added to the API, we have the sorting building block, we have the CQL building block, we have the open search building block, the various encodings and JSON, HTML, and Atom, and then each of the catalog types that I just described. Now we're going to get into a little bit of detail about the record. So we have some metadata about the record itself, the identifier for the record, when it was created, when it was updated. And then we have a bunch of properties that are used to describe the resource that the record is describing. So there's geometry, time, type. I'm not going to get into great detail here. These are all very familiar. And you know, it's sort of anyone who's looked at any of the DCAT standards or at GeoJSON, all of this will look very familiar. So these are the properties that we put in the what we call the core queryables that are part of the record building block. And we emphasize in the specification that you can extend this. This is just a small kernel of properties to get you started. Communities of interest like EDR and others will extend this. The weather people, Tom Krolitis is part of the OGC API records effort, and he's extending it for the weather people. So you know, we expect the record to be extended. These are the properties that are used to describe the collection, which is a set of records, which is a catalog, a related set of records. It's based on the collection structure that was defined in OGC API, common and OGC API features, and we've just extended it with some additional properties from records. Finally, these are the API endpoints for the searchable catalog. They should be very familiar to anyone who knows ISO 19168 or OGC API features. They're exactly the same endpoints. Just the only difference is that instead of the target resource being a feature, it's a catalog record. These are the query parameters that are part of the searchable catalog. Some of them are defined in features, others are defined in records right now, but in the end, they're all going to be pulled together into the feature specification. So we have bbox, date time limit, Q for search term searches, type searches, external ID searches, property equals value searches, sort by, and then if you want to do enhanced filtering using CQL, there are the filter language, and filter CRS parameters that you can implement on your searchable catalog to support that. By the way, if you implement something like CQL, you can also implement deep searches into the underlying information model of your catalog. So that's also a side effect of that. This is just some resources, the GitHub repo for OGC API records, the implementations page where you can access the draft PDF and HTML versions. Forget the sprint goals, that was from the code sprint that Scott alluded to. This is us, we're the chairs of the SWIG, and if you have any questions, feel free to email us, and thank you very much. Let me try to get out of here now.
Thank you very much, Peter.
Yep. I'll stop sharing in a minute if I can figure out how to
If
do that.
If anyone has any questions for Peter, please feel free. I said I wouldn't take questions till the end, but Peter can take them now. I just want you to forget about me, so you don't have questions. But any questions for Peter?
And I apologize for some of you like Clemens who've seen this presentation a dozen times already.
Sorry. He was there memorizing all the extra words.
Right.
No questions? Okay. Thanks again, Peter. Very good.
No problem.
At the end. So next, Ki-Jun to talk to us about indoor GML implementation of ISO 19164, the indoor feature model. Ki-Jun, I saw you here a little while. Yeah, there you are.
Okay, can you hear me? So I try to share my screen. So wait a minute. All right. Okay, so. I hope you see my screen.
We do. Thank you very much.
All right, great. So I'd like to give a short presentation about the indoor GML implementation for ISO 19164, which is for indoor feature model standard from ISO TC211. So I am Ki-Jun Lee, serving as an indoor GML SWIG chair, and I am working at Busan National University. So I'd like to give a very short background of what I'd like to say today is we have an indoor GML standard, which is for indoor spatial model and including schema. And as you know, we have a very interesting project for ISO 19164 indoor feature model. So the goal of these two standards are the goal for ISO 19164 is to provide a semantic classification of indoor features and the association between indoor features, while OGC indoor GML try to provide indoor spatial modeling, particularly for indoor navigation. And the scope of ISO 19164 is abstract. But the OGC indoor GML, we provide an implementation encoding schema as well. The scope, the theme that are included in ISO 19164 are mostly, the first one is indoor entity features, and the second one is entity spatial space features, while indoor GML include the geometry model, semantic model, and topology between cell, and also the so-called multi-layered space model. So these are a very short overview of these two standards. And this slide shows the relationship with ISO 19164 and other related standards like Indo GML or CTGML, IFC, and some others. So I'd like to point out that ISO 19164 in the feature model standard, it is for abstract data model. So we need some implementation. So we can provide the implementation of 19164 using OGC indoor GML or OGC CTGML or IFC, etc. So today, for this one, I'd like to give a very short presentation about how we can implement this ISO 19164 using OGC indoor GML. So this is a very top-level data model of 19164, which shows that there are many classes, but particularly I'd like to focus on the three classes within the red box. This is the scope of the implementation of ISO 19164 by Indo GML, which include the class floor and this one, abstract indoor space features and abstract indoor entity features. So I'd like to show how we can implement these three classes using Indo GML. The first one is indoor space features of ISO 19164. So the left side is the data model for indoor space features, which include floor and the room and the balcony and pathway as a subclass of abstract indoor space feature. So the right side, which is a mapping to implement this abstract space model using indoor GML. For example, we define a floor. So the bottom part of this data model of indoor GML, it is an extension of indoor GML to implement ISO 19164. For example, for floor, we define a space layer of floor. And also for space feature, we define indoor space feature layers. So by using floor space layer and indoor space feature layer, we make a collection of floor and we make a collection of indoor space features, which actually the room or pathway or balcony. So these are all the subclass of cell space, which is a very basic unit of indoor GML. And the collection of these space, like a floor and the space feature, these are defined as a subclass of space layer of indoor GML. So this is a very overall brief of how we can make the implementation of ISO 19164. And the next one is indoor entity features. So while the space features, it is for defining the space, but the entity, it is to describe the features of indoor space. So in left part, which is the data model from ISO 19164, it includes the floor, and within floor, we may attach or we may place several entities like attached features or constructive features. So we defined this attached feature or constructive feature as a subclass of cell space, and also a subclass of non-navigable space, because the constructive features and attached features, these are not navigable space, these are non-navigable space. So we define them as a subclass or the extension of non-navigable space or of indoor GML. So we define this class, and the collection of the class can be defined as a space layer called indoor entity feature layers. So this is the extension of the indoor GML for implementing the entity features of ISO 19164. Right. Okay, so this is a very brief report on the implementation. Of course, we have many other subclasses of these features, like indoor entity features or indoor space feature, but I don't want to give the detail in the presentation. So finally, this implementation will be included as an Annex E of ISO 19164 standard. And we are upgrading indoor GML, like from indoor GML 1.1 to indoor GML 2. So we may modify this implementation accordingly. Okay, so this is a very short presentation about how we can implement this ISO 19164 using indoor GML. All right. Any questions?
For questions, just if it wasn't clear to folks, indoor GML was published several years before the 19164 effort was brought forward to ISO. So it's quite nice that the two are still so compatible. And I know certainly the 19164 submitters were informed by what had been done in indoor GML as well as city GML, which there's also some relationship there. but it's quite nice that these work so well aligned. So any questions for Keisha? Yes, good.
Yeah, this is Knut from Norway. So has this only been done now as at the schema level as you presented here, or have you also actually done it with instances?
Sorry, so I can hear you clearly. So could you say again your question, please?
Did you also do this with instances or only as a schema practice as you have here?
Okay. Okay, so so this is under the development. So we didn't yet define the XML schema and the instance, but that could be a little bit straightforward task. So once we get the finalization of the ISO 19164, then we can make the XML schema and the instances of this standard.
Thank you.
Mm-hmm.
Any other questions? All right, well, thank you very much, Kishan. I appreciate it. Okay.
Right.
Yes. We have Ivana sitting in the room to talk to us about some testbed 18 work. While she gets set up. Oh, that was so quick. I'll just say OGC runs every year an annual testbed, which is a COSI, no longer innovation program, COSI initiative to look at fairly low level technical maturity research around geospatial topics and to look at those primarily pre-standardization efforts. What are those things we need to do to influence standardization and interoperability? And so, Ivana, I'll turn it over to you.
Yes, thank you, Scott, and thanks for introducing my talk as a low-level stuff. But, I don't mind.
No, maturity.
Low-level maturity. Okay.
I'm not saying you're immature, but the word might.
Yeah. Well, anyway, hi everyone. So let me introduce myself. I in this week I represent Standards Australia, but I'm also wearing all sorts of different hats. I'm the data quality co-chair, data quality domain working group co-chair at the OGC, and my primary affiliation is Curtin University, but I'm in zero capacity, but on the call affiliated with Frontier SI, one of the key partners in testbed 18 COSI initiative, as it's called now. So what was this about? We were invited to collaborate on task 27 on machine learning training data sets to do a little exploratory research on current requirements for training data sets and current options in existing standards to cater for those requirements. Main participants in this testbeds were Pixelytics and Frontier SI, and Pixelytics is a small enterprise dealing primarily with working with training data sets on all sorts of Earth observation tasks, and so does Frontier SI. I myself, I know nothing about training data sets, but I was invited as the standards person who knows ISO and who knows OGC to make sure that citation and references to standards are appropriate. We had several great staff from OGC to support us, and we had one colleague from our sponsor who was really greatly inquisitive. So he had lots of questions and lots of great ideas. Many of them were left outside of the scope of this work, and will inform next COSI initiatives, projects, or efforts, we can say. I've included a link to our repository on GitHub so that you can actually have access to the early versions of engineering reports, or as long as Scott does not disable it, it's there. So as I said, our goal was to actually research the current status and requirements for training data sets for Earth observations. And although and inform future standardization. And that future standardization is actually current standardization at OGC. And as we knew that there is an ongoing effort to develop a standard for encoding training data sets that would be useful for use in artificial intelligence. And at the time of starting our effort, which was around May this year, this draft standards was prepared for DC approval or pre-approval, I'm not sure which stage, but very close to the final stage and almost to be accepted in the form it was. Now, what we didn't want in this effort is to actually work for some fixtures, future standardization. What we wanted to do is to look at where the current draft is sitting and how does it match current requirements for training data sets. So we decided to align the two efforts, and we did align it in that the SWIP standards working group joined the testbed task, and we joined the SWIC, and we had representatives and in each weekly meetings or fortnightly in the SWIC. And one of our tasks was to actually thoroughly review the current draft and inform of potential improvement before the community approval. So what happened is that the standard has been revised on the fly, and we are currently sitting at version 3. And as it's visible on the slide on the bottom right, is that this version actually encompasses everything that has been suggested during this innovation program. So it was really practical, not just forward-looking only, but informing current efforts. If we look at the draft training DML AI standard, we see there are strong links to, or there are potentially strong links to ISO, also from the actual high-level overview of the standard. So we see things like data quality, we see things like provenance or change set or basic definition of training data, so suggesting that this might be useful to connect with existing 1900 series. And that connection is actually there. So this is the version 3 snapshot, and we can see that training DML AI has dependencies on the spatial schema standard, metadata standard, at least part 1 of metadata standard, and the data quality standard. And our various elements reused from these standards in the form of a data type or objects themselves in the schema. Now, there are 2 examples that I'd like to highlight as a result of our effort in the testbed and our review of the standard. On the left, you see before testbed task D27, the dependencies were actually referring to deprecated or superseded versions of these standards. And what we did, our current version of a standard, but not so not so efficient, perhaps for the future training DML AI standard. And after the testbed task, this has been updated. So spatial schema of the latest version and the FDIS version of the data quality standard is being used. Now, what was the implication is maybe best demonstrated on the AITD quality element, which is the element holding metadata related to quality at various levels of details relevant for training data sets, which is the scene, the object, and the pixel level. And on the left, you see the original model where there was a proposal to have a sequence of abstract passes getting into the level of the detail of the scope of relevance. And what we did, we advised to actually simplify this and use the scope, the advantage of the scope of data quality element to express various levels of details. And also we advised to actually refer to the current version of the revised 19157 so that they will utilize what I think is the best feature of this revised standard is the extensibility, whereby each domain can define their own domain relevant quality element. Now, this is a snapshot of the table of contents of the current ER coming out of this testbed. So we have not only reviewed the current draft standard, but we looked at the overall state of the art of defining training data sets, and also we've looked at requirements imposed by existing use cases where training data sets have been used, and these requirements related to metadata, to quality definition, and to cataloging all of these together. And we've completed the task with a set of recommendations to future standardization. So not only training the ML AI, but its new versions or any other related standard that might be in development. So we've put an emphasis on whenever training data sets are defined or the standards are revised for training data sets, it should be based on existing use cases and information from what works, what doesn't, and what needs to be improved. And specifically in this task, we looked at details of label geometries and data quality related to these. We've also reviewed metadata and metadata related standards from the ISO 1900 series in section 7, and advised the standard what is applicable and what should be taken into consideration, also beyond the level of obligation imposed by the standard. So for instance, we've advised on discovery metadata, which other than those 4 mandatory elements should be used in order to have an expressive documentation of training data set. We also advised on how to treat domain-specific data quality elements, so how to extend the metadata model in a standard compliant way. We've also advised to record any future measures used in quality evaluation in the future data quality measures register. And also we advised several items to consider when it comes to much more profound support for use cases, and we used existing components of the draft standard. And also we did a recommendation for fair compliance of the future standard. So how it looks like from the current standard, there are still missing elements that are not that are actually hampering the fair compliance, the fairness of the future training data sets. But we could say that all of these recommendations apply to 1900 series as well, but I would leave it here because that's a topic for another presentation for another day in another session maybe. Thank you.
You undersold your involvement because it's not just, the standards, all these quality parameters and quality aspects as well. And ultimately, the training data markup language is a quality metadata standard. It's descriptive information about your training and validation data sets that lets you know if those training data sets are suitable for a purpose. A training data set for swimming pools in Arizona is not going to work for swimming pools in Stockholm if there are any. Right? These parameters are radically different when you're taking your characteristics from imagery and such. And so this training data markup language is intended to help put those quality parameters that tell you whether the data are suitable into a common package. It's, I think, a really important piece of work, and this testbed work dramatically improved the draft standard, which was really valuable in a very short time period. I mean, in a matter of months. So,
in a very loud way, I have to say. Yeah, but I have just to add to this. I actually by intention I stayed away from section on quality because I was really curious what practitioners with training data sets think is important with respect to quality. So I didn't want to interfere with that work because I wanted to see if they say positional accuracy and completeness, if they mean the same thing or if they mean something else, just to make sure that it is clear in the standard. So I did really use this task to feed our future work as well.
I think there'd be a good natural dependency of 19157 part 3 to this standard, because where else is it going to get those measures? So it'd be good. Any questions for Ivana?
There's one online.
There's one online? Oh, hang on. Ah, sounds like a good
Hello.
catalog records use case. Yeah.
You have raised hand there, so. Good. You have raised hand online.
I do.
Yeah.
Oh, there it is. Jung Suk, I'm sorry. There you are. Now I see you. Yes.
Oh, thank you. Just, I think one thing I would like to verify, because of the metadata also considering about the data quality, right? So the data quality for the metadata, and then now is the diagram is directly defined of the data quality for the data set. So that those data quality is different, or is the same as, I mean, the same part? That is a little bit confused for me.
Yes, so let me just bring this.
Yes, here's
Yeah.
data set is
So-
aggregate of the data quality, right? But is metadata also considering about the metadata also have some field of the data quality part? So I wonder that is different or same informations.
Yeah, so we can, that's a great question. So yes and yes, it's the answer, is the short answer. So this in this model, data quality really relates to the data sets, and levels of a smaller detail or lesser scope, if I can say that. So parts of data set at the pixel level, object level, or scene level. But so in data quality standard, we also have a concept called meta quality, which really relates to the quality of the quality evaluation. But as such, data quality record of data quality is just specific type of metadata. So it just extends the metadata record with data quality related metadata. Does this answer the question?
Yes, thank you.
Okay, thanks.
Look more carefully for hands. I'm just not a zoomer. Just not a zoomer. Any other questions? No? Well, thank you again very much, Ivana. That was excellent.
Thank you.
And next, Chris Little, UK Met-Office, talk about this move from rigorous and heavy towards lighter standards and building blocks. So Chris, do you want me to present your slides, or will you take over?
I'll take over, if you don't
Okay.
mind.
Please.
Okay. Can you see my screen?
We do, but you're not in slideshow mode, so there we go. Perfect.
Fine. Okay, my talk's slightly different in the sense that it's a lot of arm waving and I'm skipping over a lot of detail, which I'm happy to provide later if people wanted it. But really, in the sense, it's trying to justify where we're going. Right? I've been a meteorologist and handling large data for decades. And basically, this is how I view data. Data comes in big containers. They're so big, you can't easily move them. And to find out what's in your crate, you usually have to open up the crate and look inside, because files like netcdf, BAM files, FITS files, databases, you look inside the file and then it tells you what's in there. And of course, quite a good idea is to stick some metadata on the outside of the crate, which we've got a little bit of metadata on that crate. But in fact, what you end up doing is you take your metadata and you stick it in its own container. And of course, that is what ISO 19115 records usually are. And I call it the biscuit tin. And of course, the more slots inside the biscuit tin you fill with the different kinds of metadata, the better metadata you've got. So here we've obviously got gold standard metadata. We've filled in all the slots. The container is much smaller than the data, so you can copy it. And of course, one of the problems with big data is you can't copy it, and we And even if you put it in the cloud, it's so big to when you create it, it is difficult to alter it. And you've got this issue of data gravity, and you've got the applications have to go to the data rather than the data to the applications, unless it's a very small subset. With the metadata, it's much smaller, so you could then say duplicate the biscuit tin around the world. The biscuit tin metadata all points back to the original data, so we're addressing some of that problem, but we still have problems. And the problems are the metadata in the biscuit tin, ISO 19115, doesn't really tell you how the data is organized in its great big crate. It doesn't tell you how to access that data. It doesn't say this data is all sequential. You have to go through it record by record till you get the one you want, or it's a direct access, or it's in a database, or it's in a ZAR format, or whatever. Right? There's very little about that. It helps you find the data, but it doesn't help you access it. And of course, the other problem, of course, with finding the data is how do you find the metadata? To which you say, well, we have a biscuit tin of biscuit tins. That's a portal. But then the problem you have is which portal do you use? And to which the answer is always my portal. The one portal to rule them all, right? And fairly sure that portals don't address the problem. And what really does address the problem is the web and the search engines, right? So here's a kind of picture of where the semantic web was 15 years ago. You connect everything up across the web and you navigate across there. You may be crawling it in not in real time, or you may be searching or whatever. And over the last 15 years, the semantic web has gone from that few big data sets to this is the linked open data cloud, and the live version of this data set is live. You can kind of just click on each of those and you can go to that data set. This is a very small subset of the linked open data on the web. It's the semantic web, because this is only things with 1,000 RDF triples in it, 1,000 relationships about the metadata, and at least 50 links to other data sets. So your data set of your personal address book is probably not on there, right? And that's, in a sense, we know that's scalable because it's on the web, and the web will support 1 billion users. And of course, we've got this idea of open data with maturity and linked data open maturity. It's a bit of a debatable point whether that linked data is working, but really what we're aiming for is lots of data is linked to other data with whatever standards whatsoever, so you can find and navigate and crawl to find the data, because we know that portals don't work, right? So my kind of view is this is what you want the data to be looking like, not like a great big monolithic crate, which is what we are, which is where we're at. I like my data chopped up so I can get just a bit of data I want, and I don't take that subset and the web or the applications and the APIs tell me how to do it, and I get exactly the pair of shoes I want, as opposed to rummaging through that great big crate with a random order. So in a sense, this is the kind of summary, right? So I sit here, I either look in the web or search engines, whichever technologies you use, whether it's RDF networks or whether it's kind of proprietary knowledge graphs, or I go to a portal. They all point me at the data. They don't tell me how to get the stuff, get the data out, or how to get the bits I want. So really, my message was all, a step away from biscuit tin. It's not a particularly strong message, but I just like the picture. So this is my kind of analysis of where we are. We've got a lot of domain-specific containers and formats. In metrology, it's netcdf, grib, buffer. In astronomy, it's FITS. In genomics, it's BAM files and VCF files. And they've all got a lot of supporting tools. They're in an ecosystem. The experts understand them. They've got control vocabularies. So in that sense, they're not going to go away. And the generic data sets, sort of storing things as RDF triples or as XML or as JSON or as binary XML or all these other protobufs or whatever all these generic container formats haven't really been successful. But the proprietary, but the domain-specific ones are, because they've evolved over the last 30 years. So they're refined and sophisticated. Metadata. Well, the summary for metadata is it's not quite good enough. And metadata is open-ended. All the metadata doesn't fit into a biscuit tin, into a single container. The fact that I've accessed a data set is metadata. and that's kind of open-ended and growing kind of metadata. Usage metadata is open-ended. The fact I find a piece of data and it's really useful and it's then reference for a important scientific paper and I want to give it a DOI, that's metadata and it's important metadata. It's all open-ended. So the rigid containers like 19115 are a good start, but not good enough. And there's not a lot of tools for creating and manipulating and using metadata. And there's no consensus on what the general extensions are. There's not much in the way of structural metadata to tell you what the data is actually like that you want to use and how to get at it, and not much in the way of query data. Now you see Peter Vetronis's presentation talked about CQL, so you can get starting to get there. You're starting to get some standard queries. The kind of example I use is because data is basically cross-domain. All the interesting things are happening across domain. An example I used to use to justify that was to find out how many whales of a species are left in the oceans. Rather than go and catch them and kill them, you would analyze a liter of seawater for its DNA, and from that there'd be enough information to tell you how many whales there are in that bit of ocean. And that used to be a sort of a slightly over the edge, kind of over the top example, but now it's becoming commonplace to do that. So the over the top example I use, you imagine you want to go to the British Library, you want to interrogate the complete works and recorded writings of Jane Austen, a famous English author. And if you do a query on pride or prejudice or persuasion or marriage, you'll get an answer. But if you actually say, please tell me the temperature in the Pacific in the year 1790, well, you're not going to get a sensible result. But actually, you should get a sensible result, because what many people don't know is Jane Austen's brother was in the Royal Navy. And the weather in the Pacific, engine response.
Chris, you're breaking up a bit. Okay, you're completely broken up now. Hello?
In the British Library is totally inadequate, right? So what you can query against. So that's my other, and this is the third idea. If you're an expert, you know which catalogs to use. If you know which portal, fine. If you don't know which portal, how do you find the portal? And the answer is search engine, right? And generally, I don't go to a portal to find anything. I just go into Google or Bing, though Google isn't as good as it used to be, and search it that way. So that's the world we're in now. So, so maybe the semantic web and RDF triples is starting to become relevant. We know the web's highly scalable and flexible. We are starting to see lots of registries that are machinable, resolvable, with control vocabularies, and we're starting to see conceptual models for specific domains. There is an issue there because, and we've had this debate in OGC about what kind of conceptual model do you mean? And there's some clear guidance I got from Rob Atkinson. He said, the abstract conceptual model is all you're interested in is the concepts and their identifiers. There are no other attributes other than identifiers. And then as soon as you start talking about attributes or properties of things in a model, that's a logical model. And then the next level down is the implementation model. And so having got perhaps some kind of layering in the abstract and logical abstract models, that allows us to use ontologies to do reasoning and to find things and do quite sophisticated processing. And I think that's the direction we're going in. But of course, the semantic formats such as RDF and its various encodings like Turtle or whatever, they're much too verbose for storing data, and certainly not environmental data, digital twin data, environmental data about the Earth. You know, we are only generating a petabyte, the order of a petabyte a day, and we're reusing it. We're not throwing it away, we're using it every day, and it goes in the archives and we want to bring it back. That's a lot of data. Okay, we're not using yottabytes, zottabytes, or, and quetabytes, the latest ones I heard of. So the idea, we're trying to get your applications to the data, you can't move the data. Metadata helps with the find, but not with the access and interoperable and reusable very much. Web's APIs help, and that's where we're going. And the experience we've had over the last 10 years, so we did quite a lot of work 10 years ago inside OGC to set up XML data models for aviation. And aviation is a global industry, lots of money, very stable environment, and their models were done in XML, but that was not easy because they were too rigid. And they didn't take into account things like half of the model was owned by the World Met Organization for meteorology, the other half was owned by the Civil Aviation Authority. So the XML models were not 100% success. And we look at industry, people are starting to do schemas. Key value pairs, much more dynamic. And fragments of schemas, just say, I just want to do this little bit. I don't, the problem with the XML model is you've got you need the whole model to validate it. If you just say, oh, I want to just validate a part of the model, it doesn't quite work. So we have this idea that we're moving to a much more dynamic environment with key value pairs and schema fragments. And that's what underpins the APIs and OGCs move into web APIs. So I've said all of that. Metadata, I've said all of that. So big picture summary, the domain-specific formats are not going to go away. Metadata is not quite good enough. We need cross-domain APIs. And of course, what we have now is with things like Swagger, we've got all the issues of authentication, authorization, management. They're all separate, right? They're all handled by the API management tools. We don't have to build them into our formats or our queries. We still need more cross-domain conceptual models. And generally, we really ought to think globally, not locally, though we may implement locally, of course. So that's my kind of big summary. And what we are doing in OGC, and in particular the MetOcean Domain Working Group and its spin-offs, is we really view our use cases are the tension between the non-expert user and the expert user. Metrology, we've really focused on the non-expert user because we really want to do scale, right? We do want to support thousands, if not more, tens of thousands of users, not one or two experts with a lot of computing resources. So that's why we published the Environmental Data Retrieval API, but it's not just environmental data, it's any data that's got spatiotemporal coordinates. So the examples I used there were, you may have a 3D scan of somebody's body, and you may want to retrieve the bone density along a path along their femur. Something that's a trajectory through 3D. That's perfectly supported by the EDR API. So anything, and those are the kind of queries we have. We have some of these patterns, get data at a point or along a line, a trajectory. A corridor is a fat trajectory, 3D trajectory, as it were, or a cube or an area or whatever. And we support, and we want to make the third and fourth dimensions, vertical and time, first class candidates, whereas of course geospatial traditionally has been very two-dimensional. And there's lots of 3D, 4D work going on in OGC, but it's not come from the traditional mapping areas. And of course, we also see ND, so meteorology, we routinely have two time dimensions. It's quite normal. Or you may have wavelength, if you generalize from image band to any wavelength, that's another dimension. And we may have categorical dimensions that are not continuous. So we support all of those. We've made it compatible with the features. We've heard a bit about the query aspects like supporting bounding box and time range. This is compatible. And as a payload, we've just agreed that coverage JSON becomes an OGC community standard. It's not published yet, but it's passed the technical committee vote. The planning committee will discuss it next week. And this is a JSON format, so it's web friendly. It could be digested by browsers. You don't need special software, and allows to take a small subset, one of your little transparent boxes or pair of shoes, and get it out of the great big crate, and then you can manipulate it locally in your browser or your friendly web client that you've got. maybe a leaflet client, for example, and that allows you to do something useful. And Coverage JSON also supports JSON LD, so we have a way of linking into the metadata world and the semantic metadata world with RDF and the semantic web. So therefore, we could start getting what we call semantic uplift, which I kind of really like that idea because metadata is quite hard to generate. We've tried to force our users to create metadata when they create their data. They don't do it. So OGC has started this register of building blocks. The building block maybe this is a bounding box in 1, 2, 3, or 4 dimensions. Here's the JSON schema that described it. Well, actually, you can then harvest that and produce some semantic description of it, an abstract model. And you can do that automatically. And that's the work in progress we're doing now. So the building blocks I've kind of just registered with the trial register are those queries about how do I get data from a point or an area or a trajectory, along a trajectory, and they may all have their sort of vertical and temporal extents as well, not just the 2D ones, but also a parameter. If I retrieve data, say temperature, surface temperature. Well, what do you mean by surface temperature, right? There are 3 major definitions in meteorology. Surface temperature of the atmosphere near the surface, which is what you expect, but it's also the surface temperature of the ocean, which is different. Or there's a surface temperature of your skin, which is another different temperature. And if somebody just queries, you need to be able to resolve a little dialogue with the user. Which one did you mean? Oh, you meant skin temperature. You want to find out if the person's going to get frostbite or not, right? So that's the kind of thing we envisage with this kind of automatic semantic uplift. So a parameter building block plugged into the control, vocabularies and taxonomy, allow people to resolve, oh, that's what you meant, right? Now I know what to do, we'll go away and search it. And so that's my thinking of where we should be going, and we are starting to move in that direction. That's end of my presentation. Back to you, Scott.
Thank you very much, Chris. Do you have any questions for Chris on these concepts? Yes, Paul.
Well, Chris, it's Paul Janssen from the Netherlands. I was triggered by your remark on the need for cross-domain conceptual models. I think you're right there. But the problem with cross-domain models is that it's always difficult to pinpoint a responsible party to that area.
Yeah, that was exactly the problem we had with XML. You know, you wanted different parts of one model to be owned by different people.
Yeah, but do you have an idea about how that should work or could work? Could OGC do something, or ISO TC211 as a larger party concerned with cross-domain models?
Mm. Well, actually, there is some OGC work that's been done by Andreas Matthias, who's a security expert in OGC, and he's been working with citizen science, and he's come up with a scheme for observations and measurements data, and actually identifying streams of it or subsets of it owned by different people. So if somebody has exposed their personal data, personal observational data, maybe temperature from their weather station in their garden, that they could kind of keep control of it, yet it could be exposed in a great big mass of data. And okay, that's kind of drilling down to each individual datum, each individual data piece of data, and have to have an attribute to say it's owned. And that person may or may not have, yeah. Obviously, you may want to keep that, you may want to float that high up the model as possible. So you group your data so by those ownership copies. But on the other hand, you may want to expose it by a different way. I think the knowledge graphs are capable of doing that. Whether they give the performance that people need for certain applications, it's not clear. Certainly our experience is if you want real performance and you're constrained by the speed of light, which we are, you have to kind of put that on one side and put everything in one place. I'm just sliding away. I'm not really giving you a straight answer, right? It's a difficult problem.
Well, yeah, you use the word knowledge graphs. I also hear that word a lot, but well,
Yeah.
I'm still waiting for it to, well, bring value to,
Yes.
to me.
Yeah. Well,
Okay, thank you.
20 years ago, I had a rule of thumb when I got involved in European Union projects was if anybody mentioned semantics or knowledge graphs or RDF, just don't go there. Just don't touch it with a 3-meter pole, right? Now the length of the pole is down to about 1.5 meters. Right? But I think we're getting there.
Okay.
I don't see any other way of doing it. We've really tried in the meteorological community, which is global. We tried 20 years ago to say when you create data, create metadata, create the catalogs, and to be honest, it hasn't worked. Right? It's too difficult. There's too much effort, and people just don't do it. Right? When you write your Microsoft Word document, it ought to be generating metadata for you. It can, but it doesn't. So there's lots of tools. Kind of the metadata aspects of the tools are deficient.
But we will work in the Netherlands on the knowledge graph in the upcoming half year.
Yeah.
So that is interesting to see what comes out of that.
Yeah.
The
other idea that I came across was discussing about, well, how would all these ontologies and taxonomies plug into a high-level ontology? And to be honest, the experts just said it doesn't matter. It doesn't matter which high-level ontology you use; they're all more or less the same. And they'll plug all the lower level bits together.
Okay.
Any other
I look forward
questions?
to seeing what you do.
Well, we are out of time for this session, and in lieu of having our discussion, what I'm going to do is I'm going to pull the pin on the hand grenade, toss it in the middle of the room with the following statement, and then I'm going to run away. And so it's increasingly obvious in OGC discussions lately that the future of metadata is not an XML file, may be attached to your data or may be lost in your file system. It's something else. And you've seen a whole bunch of different descriptions today of other ways that we have to describe our information that may not be what we think of as conventional metadata. So with that grenade going off, I'll leave it at we'll leave that for the next time we all get together in the OGC session and talk about how we're going to answer that problem. So thanks everyone for your time. Thanks all of you online who dialed in. That really interesting content.